Whether you know someone with cancer or have it yourself, everyone is affected by this tragic condition in some way. Dedicated scientists are on the way to finding potential cures for cancer that can have a huge impact on ill-fated patients. Along with chemotherapy and surgery, radiation therapy is one of many treatments that has saved countless lives around the world. Two-thirds of all cancer patients receive radiation therapy to aid in their recovery and survival. And to whom is this great discovery of radiation therapy indebted to? Marie Curie. Curie and her work with radiation therapy revolutionized the way cancer treatments have evolved by exploring new elements, encountering significant findings about radiation, and saving millions of lives by exchanging her discoveries with the rest of the world. This innovative pioneer of science was born as Marie Sklodowska on November 7, 1867, in Warsaw, Poland. Her family stressed the importance of education when she was a child, enrolling her in school at a young age. This opened her up to a world full of possibilities, including science, which she developed a great passion. Sklodowska attended an all-boys high school in her homeland, where she learned physics and mathematics, but eventually she was forced to drop out because Poland did not support the education of women. Although her father continued to educate her, Sklodowska greatly desired a degree in physics. She left Poland in 1891 to attend the Sorbonne, a prestigious university in France. While at school, Marie met the love of her life and future husband, Pierre Curie, a physics professor. Marie and Pierre began a lifelong partnership that would change the future of cancer treatment forever. However, before she even began to research radiation therapy, significant discoveries in the science field were being made by other researchers. In 1895, physicist Henry Becquerel was part of the discovery of radiation. Becquerel was experimenting to investigate the effects of X-rays on uranium when he noticed that the element had several unique properties, including emitting radiation. Inspired by Becquerel's research, Marie and Pierre delved deeper into the uncharted territory of radiation. Because of their research, the Curies were able to figure out that the rate of radiation could be measured by the speed at which an element releases a particle. Marie Curie developed a fascination with the radioactive emissions that came from certain element samples. By 1898, Curie was particularly intrigued by pitchblende, a compilation of many unknown elements, which emitted large amounts of radioactive waves. She performed several chemical procedures to separate the elements within the pitchblende, thus locating the source of the radiation. Curie compared different areas of the sample using an electrometer, a device that measures radioactivity. After many comparisons, the Curies realized that the radioactivity in the pitchblende was too powerful to be any previously acknowledged element. Soon the Curies separated the unknown element from the pitchblende and then named it polonium, after Curie's birth country. Just a few months later, Curie again encountered a strong radioactive emission in the pitchblende. In December 1889, the Curies were able to isolate this element too, and they named it radium. In 1903, the Curies and Becquerel were presented with the Nobel Prize in Physics for their discovery of radioactivity in radium and uranium. At the presentation ceremony for the Admirable Prize, Curie stated,
"Finally, we have found a new source of energy, for which the full explanation is not yet forthcoming. It will evidently give rise to new research of the very highest value in physics and in chemistry."
Curie was desperate to separate more radium from samples and perform more thorough research so that she could learn more about what radium was and what it could be used for. She and Pierre studied radium in a small, run-down shed because they could not afford laboratory space. Marie wrote,
"Sometimes I had to spend a whole day stirring a boiling mass with a heavy iron rod nearly as big as myself. I would be broken with fatigue at day's end."
The work greatly wore the Curies down, yet they persevered. A tragic carriage crash took Curie's beloved husband and lab partner, Pierre, in 1906. Although his death left her depressed and working alone, Marie decided to take over the classes that he had taught at the Sorbonne. Finally, she was able to share her love of radiation and science with those who desired to learn. Simultaneously, Curie continued to delve deeper into her investigations of radioactivity and the properties of radium. Marie coined the term radioactive after observing the particles emitted from radium and uranium. Curie explored the effects of radiation by performing many experiments in which she exposed colonies of bacteria to radiation. Curie found that the particles emitted from radium disrupted the way that the exposed cells reproduced. Exposure to radium damaged the cell's DNA. Therefore, the cell could not reproduce or grow. As Curie shared her findings, scientists began to hypothesize about whether this procedure could be used to kill the DNA of cancer cells. If Curie was right, radiation could be used to treat tumors and other malignant diseases by directly targeting the diseased cells. Suddenly, cancer had an enemy. In 1911, Marie won the Nobel Prize once again, this time for her commendable work with the elements polonium and radium. At the banquet where she received the honorable award, Curie stated,
"Thanks to this discovery of new, very powerful radioactive substances, particularly radium, the study of radioactivity progressed with marvelous rapidity. Discoveries followed each other in rapid succession, and it was obvious that a new science was in course of development."
Curie shared the importance of radioactivity and her past research with the science community. When World War I began, Marie Curie felt compelled to serve her country. Based on her earlier research, Curie realized radium could save the lives of injured and dying soldiers. Gas emitted from radium was placed in glass tubes and placed near the area of infected tissue on a soldier's body. The radioactivity from the gas then killed the infected tissue while keeping the living tissue intact and the soldier healthy. This was the first time radiation was used to destroy diseased tissue. She established 200 stationary units and 20 mobile units to treat soldiers. When World War I ended, Marie Curie opened a formal institute dedicated solely to radium research. Curie now had a place to continue her studies of radioactivity and explore even more potential uses of radium in the medical field. She loved teaching her students and hoped that her work could be used to improve future medical treatments. Unfortunately, at age 67, Marie Curie died on July 4, 1934. Ironically, Curie's death was due to radiation poisoning from the extensive exposure she received during her years of dedicated research. People would even say they saw her carrying tubes of radium in her lab coat pockets. The same work that provided life for countless radiation therapy patients ultimately ended hers. Even after her death, Curie's research was changing the lives of cancer patients. One form of treatment, brachytherapy, was developed in the early 1900s following the successful medical application of radioactivity in World War I. In brachytherapy treatment, small radioactive sources are placed next to tumors, resulting in the destruction of the targeted cancer cells, while limiting the damage done to healthy tissue. While brachytherapy is still used today for breast cancer and cervical cancer, other applications of radiation have progressed in the years since its discoveries. In the 1980s and 1990s, a combination of radiation and cancer-fighting drugs was found to be a more effective treatment than either alone. When chemotherapy and radiation were used to treat patients, doctors found that the drugs controlled the spread of cancer cells, while doses of radiation decreased tumor sizes. According to the British Medical Journal, radium, either alone or more generally, in conjunction with high-voltage X-ray therapy, is now universally recognized as the most appropriate treatment in many forms of malignant disease. Due to the work of Marie Curie and other scientists, many patients have received radiation therapy with life-saving results.
Yes, the high-dose brachytherapy would be okay for my type of cancer, and which I was delighted with because that meant it wouldn't disrupt work. I could be treated quickly and recover quickly.
As well as a technique called interstitial brachytherapy, where we can put the catheters directly into the breast so we can very carefully target where the radiation dose goes inside the breast, protecting the rest of the body, and most importantly, shortening the course of radiation.
After a lot of thought, I decided that radiation therapy was the best thing for me because it was the least invasive. It had a survival rate that was virtually identical with prostatectomy. And it was something that I knew that I could tolerate and be happy with.
Marie Curie's exploration of radium and her encounter with radioactivity revolutionized medical treatments and saved millions of lives worldwide. The legacy of her research continues to leave a lasting mark on the world of science. As she once stated,
"Nothing in life is to be feared, it is only to be understood. Now is the time to understand more so that we may fear less."
Surely, Curie opened many doors and broadened the understanding of cancer treatments for scientists, doctors, and patients worldwide. Due to her breakthrough in radiation therapy, we all are able to fear cancer a little less. Whether you know someone with cancer or have it yourself, understand that Marie Curie devoted her life to providing a healthy future for you.